video is diode component in the circuit. Diode is a semiconductor device, essentially act as a switch for current. It allows the current to flow in one direction, but severely restrict the current to flow in the opposite directions. Diodes are used for radio frequency switch, the attenuators, and used as a large volume and ionizing radiation, used for detectors and photo detectors, and used for a large scale of rectifying voltages from turning alternating current to DC current voltages. There are two types of diode. These are the base material used, silicon diode and germanium diode. There are many types of diode, as it is shown in the types of diode in the circuit in my video. These are the types of diode component in the circuit: the photodiode, the gun diode, pin diode, tunnel diode, LED, varactor diode, Schottky diode, the PN diode, vacuum diode, laser diode, and the Zener diode used in the PCB boards of a component. And here are the substitution table of diodes. As we can see, the diode with base material use and substitute. The material used is silicon with 0.7 saturation voltage, while germanium diode has a voltage saturation of 0.3 volts. There are many uses of diode. One is a rectifier diode. Second is a switch diode. Third is the clipper diode. Fourth, the clamper diode. Fifth, the damper diode. Sixth, the protection diode in the circuit. This is the illustration of rectifier diode in the circuit. As you can see, this is a half-wave rectifier diode with only one rectifier in the circuit. This is the full-wave rectifier with two diodes in the circuit. And this is the bridge rectifier diode with 4 diodes in the circuit. These illustrations of a rectifier is an electrical device composed of one or more diodes that converts AC alternating current to DC direct current. A diode is one-way value that allows electrical current to flow in one direction. This rectifier diode conducts only when it is forward bias positive voltage. The current flows through in the resistive load is one direction and pulsating voltages. This is the illustrations of switch diode in the circuit. This diode has two terminal PN junction, anode and cathode. It is used one of the application in an electrical switch. The PN junction, when forward bias, act as a closed circuit, and when reverse bias act as open circuited. The change of forward and reverse bias states makes the diode work as a switch, the forward being on and reverse being off. This is the illustrations of positive clipper circuit. This clipper diode, also known as a diode limiter. This clipping of the input signal produces an output waveform. The half-wave rectifier is a clipper circuit since all voltages below zero level are eliminated. The diode clipping circuit can be used in limiting voltages. The signal diode is a forward bias. It allows current to pass through itself. When diode is reverse bias, no current flows through it, and voltage across terminal is unaffected. This is the basic operation of diode clipping circuit. The diode in forward bias has more positive than cathode. During the positive half cycle of the sinusoidal input waveform, the diode had the input voltage magnitude greater than 0.7 volts in silicon diode, while the germanium has a 0.3 volts diode material base. The diode begins to conduct and hold voltages across itself, a constant of 0.7 volts, until sinusoidal waveform falls below this value. The diode limits the positive half of the input waveform and known as a positive clipper circuit. This is the illustrations of positive clumper diode. Positive clumper diode is made up of source, the capacitor, diode, and load resistor. The diode is connected in parallel with the output load. The positive clumper passes the input signal to the output load. When the diode is reverse bias, it blocks the input signal. During the negative half cycle of the input, AC signal is forward bias. No signal appears at the output. In forward bias conditions, the diode allows electric current through it. This current will flow to the capacitor and charge it to the peak value of the output voltage. The capacitor charges in inverse polarity, positive with the input voltage. As input current voltage decreases after attaining its maximum value, the capacitor holds the charge until the diode remains forward bias. This is illustrations of damper diode in a circuit. A damper diode is used to reduce voltage spike. The diode is normally positioned anti-parallel, positioned cathode to collector, anode to emitter, across a collector-emitter junction of a transistor. Damper diode is a high-frequency horizontal deflection circuits up to 16 kHz. The damper diode connected across collector and emitter pin of horizontal output transistor. It is called the hat. The damper diode can be found built into the hat or in the circuit because of high inductance and interwinding capacitance of the yoke and flyback transformer. The circuit must be damped out during retreat. In other words, the damper is used to prevent oscillation in electronic circuit. This is the illustrations of diode protection in the circuit. A diode is normally placed in a reverse bias in parallel with the component. When diode is placed in parallel, the component you want protected in reverse bias. If current flows through the diode bypassing the motor, reverse current flow through diode. The purpose of diode in the circuit, it is act as one-way switch for current. It allows current to flow easily in one direction but severely restricts current from flowing in the opposite directions. This is the example of diode protection in the circuit. These are the uses and functions of diode in the circuit. Next, I will show to you and illustrate how to test diode component in the circuit. The most common defect of diode that we will encounter in the circuit, one is burned diode, second, open, third, shorted, fourth, leak diode in the circuit. Hello guys, I will show to you the LED and the PN junction diode, how to test, how to know the positive and the negative terminal of a PN junction and an LED diode. These are the LED diode that I will present to you. And this is the multimeter. It shows to you the reading of the multimeter. I will put in the diode test. This is sitting in the diode test. I will check the PN junction to test this PN junction diode or the rectifier diode. This is the anode, the positive side, and this is the cathode, the positive side. This read 0.482. If we reverse, in testing, there is no reading. The same with number 2. This is the anode and this is the cathode. That one read 0.257. If we reverse, there is no reading. No reading. It means the diode is okay. This is the anode, the positive side of the tester, and the negative side of the tester. There is a reading of 0.257. This is forward bias. If we reverse this positive side of the tester, it goes to the cathode, and this negative side, it goes to the anode. This one, there is no reading. This is the actual testing of a diode. Now we are going to the LED test, so that you will know also the positive side and the negative side of diode. This is LED diode, 3 volts. You can see that if the positive side and the negative side is in the good position, the LED will light. This is the positive side, and this is the negative side. This one light. It means this is the negative side and this is the positive side. But if we reverse, there is no lights. This, we put this reverse, and this one not lighting. There is no light in the LED. But if we put in the good position, good in the positive side of the tester, this one, there is light. You see, as you can see, because this is only 3 volts, but this one, this is 9 volts. Only the forward bias can read in the tester. In the forward bias, you can see there is reading. This one, 1.712. But if we reverse, there is no reading. This one, the tester is not reading. Also this one, we have to put the positive side of the tester. This is the positive side, the positive side of the LED, and this is the negative side, the black, this front. There is reading. So the LED is good. But if we put in the reverse direction, there is no reading. No reading in the multimeter. It means this LED is okay. It will not light because the multimeter has only little volts that will flow, that will run into the LED. But there is a reading in the multimeter. This one, 1.730. The LED is okay. If the LED is short, you have read the multimeter is 0 or 0.1, like that, 0.2. And also if you reverse, it also 0.1, 0.2. The LED is bad. So this is only the practical use or testing of a LED in the PN junction diode, which is the rectifier, this one. Thank you so much, my dearest Facebook friends. Thank you so much, my dearest Facebook friends, for watching, and I hope you will understand it, like it, so that in the future you can use your course, especially when your course is on electronics and electrical and computer. You can use this multimeter, this LED diode, the PN junction diode. These are the rectifiers. You can use it to troubleshooting. Thank you, my dearest Facebook friends. This is the end of my video, and I hope I illustrate to you and educate you the diode component in the circuit. Thank you so much. Bye bye.